Hi, welcome back. In the previous lesson, we already implemented projectile for AI. In this lesson, we are going to add projectile for player character and add crosshair interface for player. Moreover, we will also implement simple damage system so that player character can apply damage to AI. Before we get into the video, I want to briefly tell you about my new released courses on Udemy. If you want to create a 2D top-down vampire-like game in Unreal Engine 5, this course is for you. In this course, you will learn pooling system to handle large number of actors, random skills, shop system with save and load framework. We will create entire leveling up system with pickable items, 2 unique bosses and 20 more mobs during the gameplay. Moreover, if you want to learn action game on mobile device, check my action game tutorial course, your own Sekiro-like basic combat mechanism from scratch by using Unreal Engine 5. Since players' mobile specifications are quite different, mobile game developers do need to optimize lots of assets and logics, including lighting, mesh polygons, textures, tick events, etc. You can play demo right now on Googleplay without ads. The link will be in the description below. Or you can head over to my Discord to check latest coupon for the courses. Okay, let's get started. Delete the wall and move player character start location. We don't need player character to hide behind the wall anymore. Open player character and BPAI blueprint. We will copy fireball logics from BPAI to player character. Make some comments. These are logics for attacking. Magic ball. Press Ctrl+C. Copy them. Switch to face player character blueprint. Paste them. We don't need these target relevant logics. Open face animation blueprint. Implement animation notify we created in the last lesson. Type anim notify. Select event anim notify an attack. Call try_get_pawn_owner node. Cast it to face player character. Call fireball custom event from this return value, from player character pointer. However, we cannot adjust target tag for projectile. For player character, the target tag will be enemies. So open BPA electricity ball. Find actor has tag node. Promote tag to a variable. Rename it to enemy tag. Select this variable. Check instance editable and expose on spawn. Compile and save, so that we can modify this variable value outside this class. More specifically, we can modify its value in spawn actor node. Switch to face player character. Right-click spawn actor node. Select refresh nodes. Enemy tag shows up. Change its value from player to enemy. Press compile. There is an arrow showing here. Don't worry, we will delete this find look at rotation node soon. Switch to BPAI blueprint. We need to define its class tag. Select BPAI in the top left corner. Search tag in details panel. Add the first default value for tags. Type in enemy. Compile and save. Right-click this spawn actor node again. Click refresh nodes. Make sure its enemy tag is player. OK. Back to face player character. Delete this find look at rotation node. Call getControlRotation. Split its return value. We only care about return value z, your value. So hook it up. OK, great. Compile and save. Let's try it. Player character can shoot magic balls to controller rotation. That's what we want. Well, it is better to add a simple user interface to show Crosshair for player. Let's do it. In the content browser, create a new folder called UI. Create a new widget blueprint. Rename it to UI underscore Crosshair. Double-click it. In the top left corner, search Canvas. Drag Canvas panel component into hierarchy to the bottom left corner. Next, search Image component. Drag it under Canvas panel component. Set its anchors into the center. Set its alignment to 0.5 in X and Y. Separately, reset its position X and Y to 0. Tweak its size to 15. It looks good. OK. Switch to Face Player Character. Add this user interface. After add mapping context in the begin play, call Create Widget. In the class, select UI Crosshair. From return value, select Add to Viewport. Compile and save. Let's try it. Crosshair is showing up. Well, I think it might be better if we can decrease its size a bit. Switch to UI Crosshair. Finally, I tweak its size to 10 multiply 10. Next, let's implement spawning projectile for player character. Find its default logics. Let's add spawning projectile animation notify for other 3 combo attack montages. Find the second attack montage. Locate its position. In this montage, FaZe attacks with her left arm, so we have to create a new animation notify for the left arm. The left arm socket will be fx underscore hand underscore L1. Copy this socket name. At proper timing, create a new animation notify. Name it to an underscore attack underscore left. Switch back to FaZe animation blueprint. Implement this new created animation notify. Attack left. Change custom event argument. Add new argument for custom event fireball. Its type is name type. Rename it to socket name. Back to animation blueprint. Duplicate this fireball custom event. Duplicate these 2 nodes again. Hook them up. So next, we need to specify these 2 socket names separately. In terms of the FaZe left hind socket, its socket name is fx hind L. Similarly, its right hind socket is fx hind R1. Compile and save. Don't forget to connect socket name argument with getSocketLocation argument. Compile and save. Continue to find the third attack montage. In this montage, FaZe attacks with her right arm. So approximately at 0.24 seconds, add an attack. This animation montage is designed for right hind socket. At last, find and open the fourth attack montage. At the right timing, add an attack left. OK, let's try it. Great. Player character can cast multiple projectiles now. OK, so far so good. We will implement simple damage system for player character and AI. Close all unnecessary tabs. Open BP AI. Create 2 float type variables. Rename it to HP and max HP separately. We will change HP value during the runtime of the game. Categorize max HP into presets, check instance editables, and expose on spawns. At the beginning of the game, we need to pass max HP value to HP variable. So call event begin play, set HP variable. Drag max HP into event graph. Hook them up. Don't forget to set max HP default value to 5. OK. Enter UI folder. Create a new head bar for AI. Rename it to UI underscore head bar. Open it. In the top left corner, search progress. Drag progress bar into hierarchy. Well, we do need to wrap it with size box first, so right-click it. In the Wrap With panel, search size box. Click it in the Details panel at the right corner. Check Width Override and Height Override. Check is variable too. Tweak its value. Let's tweak it to 100 in width and 30 in height. Change its fill screen mode to desired mode. It looks a bit small, so I tweak the width to 300. Moreover, tweak progress bar values. For example, change its color to red. Next, wrap up progress bar with a canvas panel. We want to add a text above this progress bar. After adding this canvas panel, change progress bar anchors to the last one, filling. Set offset right value to 0. Change progress bar style. I change its background color from gray to half transparent black. OK. Finally, we can search and drag text component into canvas panel component. Change its anchor to the top center. Tweak its alignment to 0.5 in X and 1 in Y. Tweak its position Y and text. I set its font size to 80 temporarily. Check Size to Content. Also set outline size to 4. Compile and save. Don't forget to check is variable. Rename this component to txt_hp. Compile and save. Switch to graph. Drag this text component into graph. Call setText function from this text component. And create a new custom event called update. Rename it to update HP. Once the health points are changed in AI, the value should be changed in the UI too. Drag progress bar into graph 2. We forget to change this progress bar component name, so switch to designer view. Change its name to pb_hp. Compile and save. Back to graph viewport. Call setPercent function from it. Hook them up. In terms of this custom event, add 2 arguments. These are float type arguments. The first one is called current HP. The second one is called max HP. Current HP divide max HP. The result is hooked with in percent argument of set% function. Moreover, in terms of setText function, call format text node, we can customize its format in this node. Type in curly braces CUR / curly braces max. Well, about their values, we have to truncate the float type variable value. We don't want digits values, so simply use truncate node, hook them up separately. Make some comments, update HP, compile and save, back to BPAI. Implement widget component, rename it to head bar, adjust its location to the top of this character, change its space mode to screen, and change its draw size to 300 in X and 30 in Y, which is accordance with user interface we set in UI head bar. In widget class, select UI head bar. Compile and save. Let's see how about this UI. It looks too big in this viewport. We need to decrease its size overall. In BPAI, change its draw size to 100 in X and 10 in Y. Next, switch to UI head bar. Decrease the text HP to 25. Well, in the design phase, we also need to set size box to 100 in width and 10 in height. This widget now is looking similar to what it is during game. Compile and save. When should we call this function? After event begin play, drag head bar component into graph, get user widget object. Cast this component to UI head bar. Promote UI head bar to a variable. Rename it to UI head bar. From it, call update HP function. Drag HP and max HP float type variables. Hook them up separately. Make sure we do this after HP is set to proper values. Compile and save. In order to see whether this logic is working or not, set max HP to 3, which is different from default value we set in UI. Let's try it. Great. Text is showing 3. Well, finally, it is time to implement simple damage system. Open BPA electricity ball actor. Before destroy actor node, call apply damage. It is a preset interface in the Unreal Engine. There are several arguments. We don't need to insert all these arguments. The first necessary argument is damaged actor, connected with other actor of a sphere component. Next, promote base damage argument to a variable. Check instance editable and expose on spawn for this variable. We need to specify damage causer. Call getOwner. Hook it up. Compile and save. Switch to BPAI. Refresh spawn actor node. We see base damage now. Call getSelfReference. Click this arrow so that we can see more advanced arguments or options. Connect self-reference with owner argument and connect it with instigator argument too. We will do the same later for player character. Set base damage to 1. Well, we are not going to set health points for player character in this lesson. Maybe we will do it in the future lessons. Call invent any damage. It is also a preset interface function. Drag set HP value here. hook it up, drag HP value again. Make sure this health points minus damage value. The return value should be clamped. The final result is connecting with HP variable. Drag max HP, connect it with max argument. After HP calculation, drag UI head bar component variable. Convert it to validated get, call update HP function. Insert current HP and max HP separately. Great. Compile and save. Switch back to the scene. Open face player character. In terms of this spawn actor node, do the similar actions, call self-reference, hook it with owner and instigator arguments. Refresh this node, set base damage to 1. Compile and save. At last, call invent any damage, but we will not add any more nodes for the time being. Let's try it. When player character shoots AI, we see her health decreases. That's what we want. In the next lesson, we are going to add healing skill for AI when AI's health is under certain ratio. If this lesson is helpful to you, please consider to support my courses on Udemy. See you in the next lesson.